Ram Ram guys, today we see about trees next part, that is properties of a tree, height, depth, level of a tree and nodes, types of tree and applications of tree. So let's start with properties of a tree. So there are mainly three properties of a tree. Which first property says that if you have n number of nodes in a tree, you have n minus 1 edges in a tree. So if you have 7 number of nodes like here, you have 6 number of edges you can count. The second property says that if there is no second property says that there is no cycle in a tree. So like if there is edge like this is not a tree because this is cycle in a tree, which is not allowed in a tree. The next property, which is final property, final important property of a tree, it says that if if only there is only one path between any two nodes, like between this node and this node, the path which is only one path is this. Between this node and this node, the only one path is this. So between any two nodes, there is exactly one path. So this is said by our third property. So the first property says that if n nodes and minus one edges. Second property says that if we don't have cycle in a tree. Third property says that there is exactly one path between any two nodes. So these are the properties of a tree. Now let's begin height and understand height, depth and level of a tree. So let's level of a tree and node. So depth of a tree is the number of edges from root to that node. So it is the number of edges from root to that node. So if I ask you what is the level of this node 2, so these are the edges from root. This is root, from root to that node. Root to this node there is exactly one edge. So depth of this is 1. Depth of 4, 5, 6, 7 is 2 because there is two edges from root node. 1, 2, 1, 2, 1, 2, 1, 2. Okay? So that's it. So now we understand what is the level of a node. It is often depth plus 1. As we see, depth of this node is what? Yes, 1. Because there is one edge from root node. So the level of this node is 2. Basically, levels of trees are count from root. This is first level. These nodes are second level. These nodes are at third level. We see on lead code that in input you given binary tree as level order traversal. We see more about that in other videos in our traversal video, but for now the levels are this. So the height of a node, longest part from node to leaf node. So if I ask you what is the height of root node, basically this is the height of tree, the height of root node, the height of node. So let's simplify it. First understand what is the height of node. So if I ask you what is the height of three node, so this is the height, or this is the longest path from node to leaf node. So here the longest path from node to leaf node is this. So this is height is 1. As we say, height is always measured from the ground. So these leaf nodes are the ground and we measure the height from it. So this is to my mind is that while talking height is that. So Ram Ram guys. So one example comes into my mind is that if I add one node here, Then what is the height of node 2? You say the longest path. I say the longest path from this node to leaf node. So this is the longest path. But one catch is that while calculating height, you don't go up. You only go downward. So its height is 1. Now this height is not 1 because longest path is here 2. There are two edges comes between this path. So this is very important that you while measuring height you don't go up, you only go down. So this is the fact. So the height of tree. So if I ask you what is the height of this tree, the height of tree is the height of root node. So here height is the edges 1, 2 and 3. So the height of tree is 3. Basically height is usually level minus 1. So here levels are 1, 2, 3, 3 and 4. So the height is levels minus 1 which is 3. So these are the basics of tree or node. So let's talk now about types of tree. So there are first is general tree. General tree is this tree which we see which can have any number of childrens, any number of childrens of a tree. It is called general tree. Like three childrens, then they have four childrens and many more. So this is a general tree which follows the properties which I taught you. The three properties which follow every tree is a general tree. That every tree which follows the properties of a tree is a general tree. So the second is binary tree. The example which we see is a binary tree. The tree in which every node has at most every node have at most two childs. That is every node may have zero child, one child or two child. So this is called binary tree. So the second and the third and the fourth, what are the different types of binary tree further? So let's take the three important types. वैसे one important type more is balanced binary tree which we study in some other class. But let's talk about these three important binary tree types. The complete binary tree is a tree in which our nodes are filled from left to right. Like this node, now this node, the next node comes here, and the next node comes here. The next node can't come here; it can come here because these in this way the complete binary tree is filled. So this is complete binary tree which fills from left to right. So this is complete binary tree. This is the example of complete binary tree. So let's take example of full binary tree. Full binary tree is a tree in which every node has exactly zero child or two child. So if this is a tree, so let comment this is perfect full binary tree or not. So no, this is not a binary full binary tree. Now this is a full binary tree because previously the this node has one child which is not allowed in perfect in full binary tree, and now every node has either zero or two child. So this is a perfect full binary tree. Full binary tree. Okay. The perfect binary tree is a tree in which all leaf nodes are at same level. If I say this is perfect binary tree or not, this is not a perfect binary tree. This is CBT or not, this is a CBT, but this is not a perfect binary tree. So let me make this. So this is now a perfect binary tree because all leaf nodes are at same level. So this is the perfect full and complete binary tree. We study more in some other class. So let's talk about now binary search tree. This is very important. So we study it in very depth because this is very important kind of tree. So binary search tree, as it is also binary tree, but in this left subtree all nodes are smaller than right subtree are smaller than root node, and all right subtree nodes are greater than root node. So this is called binary search tree. We study further it in very detailed way. So now we study applications of our tree. So what is the application of tree? Why we study trees? First thing is it is the part of DSA. This is important. The second, the application part is that it uses in file folder structure, like making the file folder structure directory, into that directory into that file. So this kind of structure is made using trees. HTML DOM, document object model, is using this tree data structure for implementation part. Heap implementation, we use CBT. The BST for searching, the BST means binary search tree. We use it for efficient searching. So these are the some applications of tree. So that's why we study trees. In next video onwards, we start some lead code questions. So let's study that. So thank you so much for watching. Bye.